All right, we're back, and in this video we're going to continue our discussion of definitions. And the previous definition that we talked about was this thing called a detection limit, or this method detection limit, also known as MDL. And we said, well, the method detection limit is this idea that we can only go so low, the game of limbo, right? So we talked about this instrumentation or these laboratory tools that we might use in a laboratory, and they have what we call a noise, and this noise is constantly there. There's nothing that we can do about it. And then when we inject something into a instrument, let's say, we hope that we get a signal from it, and that signal stands out, and here we see a signal that stands far up above what we call our noise, and this is called our signal to noise ratio, also known as S/N. So again, one of the ways that I want you to think of this is, let's say that you're at a balance, and I'm at the balance and I hit the tare button and it's 0.000, and then I take a look at the readout of the balance, and this readout is going to flop back and forth, and it's going to go a little bit high and a little bit low and a little bit high and a little bit low and back to zero and a little high and a little low. And then if we take a really tiny amount of substance and we put it on the balance pan, will that amount of substance get the balance to actually change and actually give me a readout? Because if it does, then my signal, aka my mass, is above the fluctuation that I'm getting from the laboratory tool or the laboratory instrument. So we can only go so low before the balance just doesn't register anything, it doesn't see it, and it gets engulfed into the noise, which is the fluctuation that goes up and down, up and down, up and down. So like we said last time, well, okay, this signal to noise ratio or method detection limit is really based on the instrument that I'm using, and it's also based on the actual model number that I have in the laboratory as well. So just because I use a Shimatsu and you use a Shimatsu system, let's say, that's an instrumentation manufacturer, if I'm using one and you're using one, that's great, but what if I have a newer model than you do? So that signal to noise ratio might be slightly different. Therefore, it is very important for laboratories to figure out what their method detection limits are based on the equipment and model number that they have. And then if they change that in the future, they have to go through, figure out what their new method detection limit is now going to be, because it could improve or it could decrease depending on what you chose or what your laboratory chose to do from that moment on as far as equipment goes. All right, so this leads us back to this section of definitions, and I told you that we're going to have to go through here. This is where the majority of the lecture modules are going to take place, and we want to talk about some of these definitions. And, you know, there's a lot of words here, there's a lot of paragraphs, there's a lot of definitions. It's my job just to kind of boil this down to something that maybe is going to be a little bit easier for you to remember, for you to understand, because if I don't explain it that way, then what's the purpose of me being here, right? So the very first definition that we are going to focus on after this MDL or method detection limit is something called a surrogate. All right, so surrogates are very common in most laboratory methods that you're going to see out there. Surrogates have a particular role, and it's going to be our job today to figure out, well, what is a surrogate and how would someone make one, and what is the purpose of that, right? So surrogates in methods are typically abbreviated as SA. So the S, of course, stands for surrogate, and the A is actually going to stand for, most of the time, what we call an analyte. All right, so an analyte, oh gosh, look at my page. I've got so many windows. All right, so the analyte is going to be something that we look for. That is the term that we use. So this is something that we're trying to measure or something that we're trying to look for. That is in terms or in reference to analyte. So a surrogate, number one, is typically unlikely found in the sample. So this is something that we're not going to see most of the time if we run samples, no matter what kind of samples that we have. This is something that is traditionally not found there at all. And again, I'll talk about this here in just a second on why this is important. Number two, not only is it not commonly found in samples, but it's something that I add. I do it, all right? And I do it in a known concentration. So I'm going to add a certain amount, and that amount I will know what I've added because I did it, right? Or someone else has prepped it and they have let you know about it. So a surrogate, number one, is not found in a sample for the most part. Number two, it is something that we add to the samples as we run them, and that way we know how much, right? This is going to give us an idea of something a little bit later on in the data in the report. Number three, because we've added it, it should show up in the report. So if I run a sample, maybe the stuff that I'm looking for sample-wise is not there, but the surrogate is going to be there because I know that I've added it in there. I know how much I've added it in there, and I know that it should show up on the report. So that's one of the things that we're going to look for in terms of quality control. It is this idea that I've added something and the machine or the instrument is seeing that something that I've added, and it's going to kick back a data number or a report number that's going to be very important for me. All right, and then finally, the purpose of the surrogate here is to really check the lab prep method. That is why we use this thing for the most part. So let's imagine a instance where people are working in a laboratory and they're processing samples one after another, after another, after another. So if we don't put any checks in place, what will happen is that these particular samples will be analyzed. They will generate some data. They'll put that data into a report and it will kick back a number. Okay, great. You process samples. But how do you know if you process samples the proper way? I don't know that. I wasn't there with you when you did it, right? There could be 20 different lab workers in a lab doing this measure, doing this thing of this processing and running samples and getting data and putting them in spreadsheets. Okay, how do I know they did it the right way? Well, one of the things that happens is the surrogate is included in the samples, and this will test the lab prep methods that go on in a lab environment on a daily basis. So what will happen is that if I add the surrogate, I know how much I've added, and I let the lab workers process the samples like normal, aka processing the surrogates as well, right? Because we've added those surrogates in there. So we're processing those surrogates. We know how much is there. And hopefully the end of this, when they kick back the data, the surrogates will match what the concentration of the expected value is supposed to be. If it does, then that means the lab method was followed correctly. They processed the samples the right way. They handled them the proper way. The machines kind of saw the right things that they were supposed to see. And that's the idea of what a surrogate is. So the reason that we unlikely find them normally is because this is something that we want to add that's not going to already be present, because if it is present already and then we add to it, what will happen is that our concentration will be greater than what we expect, and that's going to throw off our data if we're not very careful. So you need to know a little bit about your samples. You need to know what will be there, what is normally kind of traveling through the processing and the analysis of the sample, because you want to pick a surrogate that is not going to be present at all. And then we add that in because we're adding a certain amount. We know the concentration. We know what should be on the report. And if that stuff is already present in the sample, even in the slightest, it's going to throw that whole number and that calculation off. And we're going to think that we did things the wrong way when actually we didn't. So that is the definition of a surrogate. Now, here is the purpose of the SOPs. So the method is going to tell the company you need to pick a surrogate. And they don't sometimes just deliberately say what the surrogate's supposed to be. Sometimes they do, but sometimes they don't. And they're going to leave it up to the company to make that decision on their own. So in the SOP, all of these that we're getting ready to talk about will already be ID'd and established by the time it goes to the lab worker. So again, the SOP is our straight up directions. We follow the directions as they're written. We don't make any changes, and everything's going to be just laid out for us from step 1 all the way to the very last step. So surrogate is part of the method. Sometimes the surrogate is not identified. They let the company make that decision, and then the company will make that decision that's best for them, and then they will include that in the slight modification that we call an SOP. All right, so here on the screen, you're seeing that method 524 that we pulled out from the EPA. I'm just going to zoom in a little bit. That way you can see the writing a little bit more. So under the definitions, you're going to see something called a surrogate analysis, and it says abbreviated SA. And it says it is a pure analyte, which is extremely unlikely to be found in any sample, and which is added to a sample aliquot in known amounts before, that's the key, before the extraction or other processing. So we're going to do this in the very beginning before lab people get their hands on treating the sample, processing the sample, filtering the samples, digesting the samples, whatever the case is. It's before all of that takes place, and is measured with the same procedure that is used to measure the other sample components. So, of course, if we're going to use a machine to analyze something, well, we want that same machine to be able to see the surrogate or whatever we add into there as well. The purpose of the SA is to monitor method performance with each sample. So we're monitoring the laboratory procedures and the methods to make sure they're handled and prepped in the proper way. All right, so that is a surrogate analyte, an SA, and very commonly found in many methods. Outside of the EPA, absolutely. So again, I told you in the other videos, EPA does a really great job, I think, explaining all of these in detail, including as much detail as possible, and we can use this one example and really just apply it to other things that we find in a laboratory arena as well. All right, so that is the overall summary of what a surrogate is. Again, unlikely found in a sample. We're going to add that concentration. We'll know how much it is. It should show up in the report, so we hope we get a signal from it, and that value should match the expected value. And this helps us to determine, did they handle and did they process samples accordingly? Okay, so that is one of the definitions now that we can check along with MDLs, and in the upcoming videos, we're going to just dedicate a video to each and every single definition that we're going to see here that are going to be the most important for now. And in the next one, we'll move on and we'll talk about something called an internal standard. So, again, crack your knuckles, get out your paper, get out your pens. You're going to take some notes because a lot of this is going to be new information for many people, no matter what your background is.